which is T into Z formula. So after substituting of all these values, we got ASTX, which is, understand this, ASTX stands for middle tension steel reinforcement along short span, which is 276. But as per the code, what is minimum steel we have to provide? This 276 is as per design. But as per code, minimum AST is 0.12% of BD, which is 180 mm square. Now check these two values. As per design 276, as per code minimum steel is 180. So what is the final AST? 276 itself, the greater values. Now after that, spacing calculation using 8 mm diameter bar, the spacing will be 181. We got 181 and this rounded to approximately, this symbol represent to approximate 180 mm. You cannot just select this as final. We have to check for maximum spacing, which is 3D and 300. So one is 375, another is 300, another is 180. What is the least value out of this? 180. So the final statement is provide 8 mm diameter bars at the rate of 180 mm center to center along short span. I already told you, please highlight this statement. Why? Because we have done all the procedure till now. That is only for this statement. This is the final output of design. That's why highlight this. And where you have to provide this where we have to provide this reinforcement along short span in the middle strip only. Okay, and alternate bar should be bent up. మనం పెట్టే ఒక్కొక్క బార్లో ఒక బార్ బాటంలో నుంచి స్టార్ట్ అయితే ఇంకో బార్ టాప్లో నుంచి స్టార్ట్ అవ్వాలి. దట్ ఐ విల్ ఎక్స్ప్లెయిన్ ఇన్ డీటెయిల్ ఇన్ ద డయాగ్రామ్ అట్ ద ఎండ్. Next, reinforcement along long span, same procedure, but I already told you dy. Effective depth along short span is different, along long span is different. So after substitution, we got 226 as ASTY, okay, which is also greater than minimum. Minimum in the 180. So 180 కంటే ఎక్కువ ఉంది. So we will finalize this as ASTY. In the same way, spacing also calculated, which is 220 mm. Okay, so for this also we have to check maximum spacing, which is 3D and 300. Okay, and here 220, 350 and 300. The least value is 220, right? So provide 8 mm dia bars at the rate of 220 mm center to center along long span. And ఇది ఎక్కడ పెట్టాలి? మిడిల్ స్ట్రిప్ లోనే. All these are main steel itself. And alternate bar should be bent up. Y direction అయినా కూడా bend చేయాలి. అదే one way slab లో అయితే in Y direction we are not providing main steel, we are providing distribution steel that will not be bent up. Only main steel will be subjected to bent up, alternate bars bent up. Okay, next, main steel in X direction, main steel in Y direction, both are completed, and that steel we will provide in middle strip only. And the steel in edge strip, that we have to calculate now. So as per the code, what is the amount of steel we have to provide in edge strip? Minimum reinforcement. Okay, that is no need to calculate again. Already we have calculated in step number 7, which is 180 mm square. For that, spacing is calculated, which we got as 270. But the code suggests maximum spacing. Check for maximum spacing. Remember, for distribution steel and for edge strip steel, the maximum conditions are 5D, 450. But for main steel, it is 3D or 350. Okay, remember these two. Next, maximum spacing. After checking maximum spacing, we got 625 and 450. Now compare these three values: 270, 625, 450. Out of these three, the least value is 270, right? Hence, provide 8 mm diameter bar at the rate of 270 mm center to center in edge strip only, in both directions. Both directions అంటే మీనింగ్ ఏంటి? అలాంగ్ ఎక్స్ డైరెక్షన్లో ఉన్న ఎడ్జ్ స్ట్రిప్లోను ఇదే స్టీలే పెట్టాలి, అండ్ అలాంగ్ వై డైరెక్షన్లో ఉన్న ఎడ్జ్ స్ట్రిప్లోను సేమ్ స్టీల్ పెట్టాలి. ఓకే, ప్రొవిజన్ ఆఫ్ స్టీల్, ఎవ్రీథింగ్ విల్ బి ఎక్స్ప్లెయిన్డ్ అట్ ద ఎండ్ ఆఫ్ ది ప్రాబ్లమ్, వేర్ యూ హ్యావ్ టు ప్రొవైడ్ ఆల్ దీస్ థింగ్స్. Diagram is very, very important. And the last step of the design is check for deflection. Actually, design is completed. Why? Because along X direction steel is finalized, along Y direction steel is finalized, along edge strips also calculated. So that's why design is over. Now the last step is check for deflection. Okay, and you know how to calculate depth required to resist deflection, which is L by basic value into modification factor. For that, basic value is 20, Lx is already known, but the only unknown is modification factor. How to find modification factor? First of all, find out percentage of tension steel. Okay, percentage of tension steel is required. Then we have to, by using this, we have to find MF, which is modification factor from table number 4. I will show you for this problem. Okay, and one more important thing is we are checking deflection along short span at the center, right? At the center, what is the formula for percentage of steel? AST, small AST by spacing into D into 100. I have said many times the formula for percentage of steel is AST divided by BD into 100. This is the formula, actual formula. Area of total steel divided by width of member into depth of member into 100. ఓకే, ఇది కాకుండా స్లాబ్స్లో ఇంకా ఈజియెస్ట్ వే, దట్ ఆల్సో ఐ హ్యావ్ సేడ్, దట్ ఈజియెస్ట్ వే ఈస్ ఇన్స్టెడ్ ఆఫ్ టోటల్ ఏఎస్టీ యూ జస్ట్ సబ్స్టిట్యూట్ one bar area, not all bars area, just one bar area. And instead of substituting entire width, just substitute spacing. Instead of entire width, just substitute spacing. And the remaining thing is same, into depth into 100. This is the formula. That is what we have done here. Small AST by spacing of main bar into 125. Listen carefully. This spacing is always x direction middle span spacing. It's not x direction edge strip spacing. It's not y direction main strip spacing. It is always x direction middle strip spacing. Okay. And after substitution we got 0.2% as percentage of steel. Now for 0.2 percentage of steel, what is modification factor? I think it is page number 37 or 38. Yes, it is page number 38. Out of this, which graph I need to consider? Fs equal to 240. Why always Fs equal to 240? It is not a constant parameter. See here, Fs equal to 0.58 times of Fy. In that Fy, you just substitute 4 and 5. Then you will get a value which is very close to 240, 240.14 or something. That's why we are considering the second curve. That means from the bottom it is second curve. Okay. If the grade of steel is given as Fe 250 or Fe 500, this Fs value will be changed. That means the curve will be changed. Based on that, you have to consider. Okay. For example, we have in the question, they have given Fe 500 grade of steel. Instead of Fe 4 and 5, they have given Fe 500 grade of steel. Then what is Fs? Fs equal to, the formula is 0.58 times of Fi. 0.58 times of Fi. How much? 0.58 into 500. It's 290. For this, the value is 290. Then which curve we have to consider? This bottom one. Okay, the bottom curve we have to consider. So it's all depends on the grade of steel given. In our case, the grade of steel is 4 and 5, right? That's why we are considering this curve, Fs equal to 240 curve. Now, for our case, what is percentage of steel? 0.22. Where you will get 0.22? This is 0 and this is 0.4. That means this will become 0.2. Okay. And 0.22 is our value. If it is 0.2 and the center one will become 0.3, right? This is 0.2 and the center value will become 0.3. 0.3. And in between, you just imagine 10 divisions. In that 10 divisions, our second division will become 0.22. Let us take some line. So this will be your 0.22 line. Okay. And from this, you just draw horizontal line. You will get modification factor. Okay. How much we have taken in this code? 1.6. Okay. Here it will be somewhat greater than 1.6, 1.62 or something. Okay. 1.62 or something. Okay. I have to consider 1.2. It's not a big deal. Next, after knowing modification factor, the next step is substitute the values. We got 113.28 mm. Now what we have provided is 125. As per design, to avoid deflection or to resist deflection, the minimum depth required is 113. And how much we have provided? 125. Hence it is safe against deflection. So provided depth is sufficient. Okay. This is the design of a two-way slab subjected to simply supported condition. Now let us discuss in detail about the diagram. Okay, very important. Understand carefully. And before studying about the cross section, first we'll study in detail about plan, so that the cross section will become very simple. Understand carefully. And if you want, you can zoom the picture, but ఇప్పుడు నేను జూమ్ చేసినది మాత్రం అలాగే వదిలేస్తే బెటర్ మా. మీరు సపరేట్గా మళ్ళీ జూమ్ చేసుకుంటే నేను ఏ కంటెంట్ ఏ లాస్ట్లో చెప్తున్నానో మీకు అర్థం కాదు. ఓకే, నౌ ఫస్ట్ థింగ్ ఈస్ draw the external line which shows the outer width and outer length of the slab. అంటే 3800 by 4600. అసలు ఈ వాల్యూస్ ఎక్కడి నుంచి వచ్చినాయి? How you got these values? Just a minute. First, let us see the dimensions of this slab given in the question. So what is the dimension of the slab given in the question? 4000 by 3500. And width of this slab or width of the support, which is not given here. Okay, let us assume 300 mm. In this it is not given. Let us assume 300 mm. Now okay, so this one internal, that means front spacing plus here 4000 is given dimension, right? For that 4000 on this side you will get a 300 mm width, on this side you will get 300 mm width. Total it will be 4600. And a small correction here, the internal spacing given is 3500, right? The internal center to center spacing, not center to center, clear spacing. Let me draw a picture here so that you can easily understood. Internal spacing is given as 3500. Now I want the outer to outer. How to get this? Internal to internal 3500 plus 300 on one side and 300 on other side. So total 4100. You will get 4100. So instead of this 3800, you just simply note it down, 4100. I will send the total two-way slab material to your CR now after completion of this session. You just collect it and make this correction in that material. Okay. And one more important thing, already I have sent two-way slab up to this page, only up to this page. But I have added many problems in the same material. So with a name of two-way slabs updated, like that you will get a file today. You just take that file for two-way slabs, not this one. మీకు ఆల్రెడీ పంపించిన దాంట్లో ఇక్కడి వరకు మాత్రమే ఉంటుంది. సో అది వదిలేసేయండి. కొత్త ఫైల్ టూ-వే స్లాబ్ అప్డేటెడ్ అని వస్తుంది. అందులో అన్నీ ఉంటాయి మనం, ఫ్రమ్ ద ఫస్ట్ టు ఇంకా రిమైనింగ్ నేను కొత్తగా యాడ్ చేసిన ప్రాబ్లమ్స్ కూడా అన్నీ ఉంటాయి. ఓకే, నౌ కమింగ్ టు ద డిస్కషన్. You just draw outer to outer width of slab, which is 4100, and outer to outer length of slab, which is 4600. Now you will get one rectangular box. That's it, right? Next one, okay, let me draw with red color so that we will get what is the diagram and all. మా ఇప్పుడు ఆల్రెడీ డయాగ్రామ్ ఉంది, బట్ ఇప్పుడు కొత్తగా డ్రా చేస్తున్నది సీక్వెన్స్ ఆఫ్ డయాగ్రామ్. గుర్తుపెట్టుకోండి, అలా డ్రా చేయాలి. First you have to draw this rectangular box with outer to outer length and outer to outer width. Now it is completed. Next part is this one. This is the reinforcement along longer span. We have designed this one with 8 mm diameter at the rate of 220 mm center to center. Okay, at the rate of 220 mm center to center, just beyond line. And listen 1 minute, just a minute.